to understand the principle of superposition, consider the charges Q1, Q2, Q3 and Q4 as shown. Here you can take any number of charges. Let vector R1, vector R2, vector R3 and vector R4 be the position vector of charges Q1, Q2, Q3 and Q4 respectively. Let us find the forces on Q1 due to rest all the charges. Force on Q1 due to Q2 is vector F12 is equal to K into Q1 Q2 upon R12 square into R21 cat vector. That is equal to K into Q1 Q2 upon modulus of vector R1 minus vector R2 square into vector R1 minus vector R2 upon modulus of vector R1 minus vector R2. Therefore, vector F12 is equal to K into Q1 Q2 upon modulus of vector R1 minus vector R2 cube. Vector R1 minus vector R2. Similarly, the force on Q1 due to Q3 is equal to vector F13 is equal to K into Q1 Q3 upon modulus of vector R1 minus vector R3 cube into vector R1 minus vector R3. And the force on Q1 due to Q4 is vector F14 is equal to K into Q1 Q4 upon modulus of vector R1 minus vector R4 cube into vector R1 minus vector R4. The Coulomb force on any electric charge is equal to the vector sum of the individual forces due to each charge. This statement is known as the principle of superposition. This principle is experimentally established. Now, according to the principle of superposition, the total force on the charge Q1 will be vector F1 is equal to vector F12 plus vector F13 plus vector F14 and so on, vector F1n. In general, if Q1, Q2, Q3, Qi, Qj and so on to Qn are the electric charges, and vector R1, vector R2, vector R3 and so on, vector Ri, vector Rj and so on to vector Rn are respectively the position vectors, then the total force acting on a charge Qi due to all the rest charges is vector Fi is equal to sigma j is not equal to I, j is equal to 1 to n, vector Fij. Therefore, vector Fi is equal to K into sigma j is not equal to I, j is equal to 1 to n, Qi Qj upon modulus of vector Ri minus vector Rj cube into vector Ri minus vector Rj.